All right, good afternoon, Accelerated Algebra. Tomorrow you will have your quiz on lessons 1.4 to 1.7. So to review today, we're going to do all the check your understanding sections in those notes. So you can open up to your 1.4 notes. The check your understanding will be below your quick notes. So take out your binder, take out your 1.4 notes, and you'll see this at the top. We're going to do the check your understanding below that. You will get 5 minutes by yourself. Please note I said by yourself. I want to see what you remember about this lesson by yourself, and then I will explain in this video the answers. So the sub will pause this video. You'll get 5 minutes to look at this on your own. If you've already done some of the questions, look back through your work and see if you still agree with it. And then the sub will play the video and you can see your answers. So go ahead and take your 5 minutes on 1.4, check your understanding section. All right, for number 1, hopefully you recognize your term n just has to multiply by itself to get the term value. So you would get 5 times 5 is 25, 8 times 8 is 64. So the relationship, you take the term number times itself. Well, we've been letting our term number be n. For any term n, you would do n times n or n squared to get the term value. Then we get to this pattern here. Remember, we're always trying to see how we can relate the figure number to our pattern. So in all of them we can see it's 3 high, except the first one. The rest of them are going to be 3 high, and the width is going to match the figure number. So figure 2 is 2 wide, figure 3 was 3 wide, 4 was 4 wide, so figure 5 would be 5 wide and 3 high. But if you notice, they're all missing this bottom corner. So it would be 3 high, 5 wide, missing this corner. And so, in figure n, they would all be 3 high, n wide, missing the corner. And so that could get you this expression, 3n, or 3 times n, to get the area of that rectangle, minus 1. This is not the only expression. If you found a different expression, I encourage you to simplify it. And when you simplify it and combine your like terms, it should simplify to 3n minus 1. If you're not sure that your expression is correct, you can show me tomorrow when we return to class. Okay, go ahead and open up. We just did the 1.4, check your understanding. Go ahead and flip to the 1.5, check your understanding. You'll get another 5 minutes by yourself to work on it, and then the sub will play the video to show the answers. So go ahead and flip open to 1.5, check your understanding. Okay, so here in 1.5, number 1, you're told that the first month of this radio subscription, they're just going to charge you $2. After that 1 month, then they go back to their regular price of $11 for every month. So let's break down each person's equation. Dara's equation is saying exactly that. This $2 for the first month, we're just going to pay 2 straight up dollars for that. But then they're going to charge you $11 times every month you have after the first one. So whatever months you're on, you're going to take off the first month because that's already paid for in this $2. So that's where the m minus 1 comes from. For every month after the first one, you'll multiply that by $11 to see your total. Pax's equation did it a little differently. He said, let's charge $11 for every month. And then he's like, well, that doesn't account for that first month only being $2. You overpaid by $9 that first month. So we can say, let's charge $11 for every month, but we'll take off $9 for what you overpaid by. So they are actually both correct. They're explaining the expression in a different way, or the cost, but they are both correct. In fact, if we simplify Dara's expression, if we distribute that 11 to the m minus 1, that would make it 11m minus 11, and then we combine our like terms. 2 and negative 11 combine to be the negative 9 in Pax's equation, and that 11m comes down. They simplify to the exact expression. So they're both right, they just have them in different expressions, and that's okay. That's what we did here. We said multiple rules can be right. They simplify to each other, but they might be written originally in a different way. Okay, then we got to this number 2. We might have started this one in class, but I'm going to show all the steps. The correct answer would be D. You can see that in each situation, when you distribute and combine your like terms, they each equal x squared minus 5x except D. I'm going to have the sub pause here for a little bit until everyone agrees that it's D. Once you agree to that, then you can go ahead, take your 5 minutes to go to the next check your understanding in 1.6. So once you can agree, we're going to move to the 1.6 check your understanding, work for 5 minutes by yourself, and then we can go ahead and play the video of the answers. All right, notice there are 2 parts of this. You have to specify if it's arithmetic, geometric, or neither, and then you have to give your reason. So remember, arithmetic has a common adder or subtractor. Geometric has a common multiplier. And if it's neither adding nor subtracting or multiplying, then it's a neither. So you could see the first one is arithmetic. We're just decreasing by 5, subtracting 5 each time. The next one is geometric. When we have fractions, we multiply the numerator by something and we multiply the denominator by something. We can see that each numerator is getting multiplied by 2 and each denominator by 1. So you could say it's getting multiplied by 2 over 1. That does simplify to 2, so if you just said it multiplies to 2, that also works. C is going to be neither. We can see right away it's not arithmetic. From 1 to 4, we'd add 3. So if it was arithmetic, plus 3, we get 7 next. If we do a multiplier, we're like, okay, 1 times what will get us 4? Well, that would be times 4. So we would expect times 4, 16 would be next. So right away, it's not arithmetic, it's not geometric, it would be neither. The last one's tricky. If you tried adding 4 plus 2 to get to 6, plus 2, 8 would need to be next. So you know it's not arithmetic. And geometric, you may say, okay, well, 4 times something has to get to 6. Right away, you might know it's not a multiply by a whole number. And so that's where you would say, this little side problem over here, 4 times something has to get us to 6. Well, if we want to know what that x or that something is, we can divide by 4 to get that multiplier by itself. If we divide by 4 here, we divide by 4 here, and we see, oh, it would be 1.5. 4 times 1.5 gets us 6. 6 times 1.5 gets us 9, and so forth. You can keep checking that times 1.5. Remember, we had said if the multiplier is between 0 and 1, the terms decrease. If it's greater than 1, the terms increase. Well, the terms increased, so we knew our multiplier had to be greater than 1, and 1.5 is greater than 1. Let's see an example of when it might decrease. Grandma Fletcher made her cookies, and she made 2/3 of the previous week's amount. Right away, you can see 2/3 is between 0 and 1, so her terms better decrease here. If your terms increased, you might have done some division instead of multiplication here. What we're doing is in week 1, she has 243 cookies. We're multiplying by 2/3. We're multiplying by something smaller than 1, so we should see that the next term gets smaller. The next term gets smaller, and so forth. So remember, we're multiplying. If you're not sure how to do this in your calculator, all fractions are division. So you would do 243 times parentheses 2 divided by 3, close your parentheses. If you're not sure how to do that, tomorrow when I come back, let's double check that. But you would see the table answers A and B. In week 2, you would multiply your cookies by 2/3 and see 162. To get to 72, you'd have to multiply by 2/3, multiply by 2/3, and so you'd see 72. When it asks about 32 cookies, now you're seeing in this bottom row when it gets to 32. So you'd have to multiply by 2/3 again, not 32. Multiply by 2/3 again, and we get to 32, so we would see in week 6. This is a geometric sequence because there's a common multiplier. Remember, geometric sequence is all about multiplication, and it has to have a common multiplier. So we would say, yes, this is geometric. All right, let's go to your final check your understanding. Let's go to lesson 1.7, check your understanding. Take 5 minutes on your own to look at it, see what you know, and then the sub will play the rest of this video to reveal the answers. All right, you are asked if this table and this graph go together. We can see they overlap the point 1, 2, and 3, 8, so it kind of looks like they could. However, they are not the same. The first one, we learned that arithmetic makes a line. There's a common adder. We're going to add the same amount in each x and y direction. Add and add. We can see in this table, to get from 2 to 4, 4 to 8, 8 to 16, we had to multiply by 2. So in this table, it's a times 2. And in this graph, it's not a times 2. It's a linear thing, so it would be, to get from 2 to 8, we'd have to increase by 6. But then in between, divide by 2, we'd have to add by 3. So we would add by 3, add by 3, add by 3. Adding by 3 is not the same as multiplying by 2. You don't have to get that specific. You could just say that this was a linear thing, so it was arithmetic, and this was a multiplier, so that automatically makes it geometric. These two cannot go together. Lastly, there's a lot here, I'm just going to show it all. You are told a petri dish, the bacteria doubles each day. So on day 1, you're asked to represent the sequence in at least 2 different ways. Remember we talked about how you can represent it in a table, a graph, an equation, or a picture, or words, but the words are already given to you. This one I would recommend not doing a graph. I think a table, equation, or picture would be best. So day 1, here's my little petri dish. There's 7 bacteria. If it doubles, day 2, there would be 2 petri dishes with 7 bacteria in each. Day 3, each of these petri dishes would double, and so we could see there would end up being 4 petri dishes of 7. So that would be if you're going the picture route. If you're going the table route, on day 1 there's 7. Day 2, if it doubles, there would be 14. We could see the 7 and the 7. If that doubles, there would be the 28. Each of these doubles to 7, 7, 7, 7, and so forth. You could continue your table. The equation, you're taking 7 and you're doubling it, so that's the times 2. And yesterday we briefly talked about how there would be exponents in a geometric situation. If you are repeatedly multiplying by 2, you are going to have an exponent. And at 2, you only multiplied by 2 one time. To get to day 3, you multiplied by 2, multiplied by 2. So you multiply by 2 twice. In other terms, your exponent is always going to be 1 less than your day number. So 4, you did times 2, times 2, times 2. So you multiplied times 2 3 times to get to 56. And so it's always 1 less than your day number. I do not expect you to have the equation memorized yet. I briefly taught it to you yesterday, so maybe that makes sense to you, or maybe you're like, for this one I would do a table and picture. You are then asked to expand this to when there would be 3,584 bacteria. I would say the table would be the easiest. If you double it, 56 times 2, times 2, times 2, you could go ahead and expand your table, and you would get day 10. If you got your equation, you could go ahead and plug in values for your day number, and you could guess and check till you get it, and if you put 10 here, you would get this amount of bacteria. Okay, quiz tomorrow on sections 1.4 to 1.7. Study tonight, look over your quick notes, look over these problems we did again today, and if you have questions, we can start tomorrow's class with a couple minutes of questions. Have a great rest of your day, Accelerated Algebra.